Hello students. So we have been solving the physics section of the JEE main paper of 2017, and this question is from the question set D, and the question is question number 43. In this question we have been given an electric dipole placed in an electric field under two different cases. The two different cases is that, now first let's understand what's given about the dipole. So electric dipole is the fixed dipole moment. The dipole moment of this electric dipole is not changing, and it's making an angle theta with the x-axis. This is the information which we have been given regarding this dipole. Now there are two cases to which this dipole has been subjected to. Two different cases of electric fields. The first case, the electric field is along the x-axis and its value is Ei cap. In that case, the torque experienced by this electric dipole is nothing but equals to tau k cap. This is the first case in which the dipole has been subjected to. The second case is that my electric field is now equals to root 3 times E, that is E is the magnitude of the first electric field. Now, but this is in the y direction, that is j cap. In that case, the torque which is experienced by this dipole is nothing but negative of what it was experienced in the first case. So using these two information, we have been asked to find out this value of theta that this electric dipole makes with the x-axis. Now we know that the angle, in order to find the angle of theta, we first need to find out what's the value of torque using these two conditions. So the formula which we are going to use over here is that torque is nothing but P cross E, where P is the electric dipole moment of this electric dipole. As we know that the electric dipole moment is fixed for this, we can assume it to be equals to Px I cap plus Py j cap. Having all these information, now we will try and proceed with the solution. So using the first case, I'll use this formula. So in first case, my torque is nothing but equals to tau k cap, whereas in the formula P, I can assume it to be Px I cap plus Py j cap. Now, in place of the electric field, I can write it as E I cap. So on solving this, when you open the brackets and multiply all these things, you get the value of Py is equals to minus tau by E. So this is the first thing that you get on solving the first equation. So out of Px and Py, I now have my value of Py. In order to find the value of Px, all I need to do is use this again using the second condition, that is when my electric field changes. So in that case, I know my torque is nothing but negative of what it was in the first case. My P remains same because it's constant and is equals to Px I cap plus Py j cap. In this case, you must notice that the electric field has changed and it's now in the x, instead of x, it's in the y direction and is equals to root 3e. And j cap, that gives the direction. On solving this, I will get my Px is nothing but equals to minus tau of root 3e. The calculation of which I am not showing right here, you can do it once you are solving it once again. So these are the two values which I get. Now in order to find the value of theta, what I need to do is I have to find the value of tan theta, which is nothing but Py by Px, which is equals to root 3, which is fairly simple, and hence I get my value of theta, that is equals to 60 degrees. So the angle which the electric dipole makes with the x-axis is nothing but equals to 60 degrees. So I hope you were able to understand this solution, and if you really like our solutions, please subscribe to our Toppr channel, and not only that, please hang on to this channel as we'll be uploading more and more solutions very soon.